Yes. What do you mean? Oh, yes, it does matter. Because it's either, if it's just that 2 just inside, then it means, then it means it looks like something like this, which is impossible. Yeah, I know, it's a typing error. Ja, nou ja, dan sê dit dan het jy 2 van hierdie, soos hierdie ene plus hierdie ene, maar hulle is nie aan mekaar gebind nie. Okay. Afrikaans moet ek weer herhaal. Almal fine. Okay. Right. Now we're going to look at the ionization constant for water. This is a very important concept to understand for calculations, vir berekening. Die ionisasiekonstante vir water, and that is a Kw. Okay. So on the right hand side, this is not a definition, not the definition. On the right hand side, you have the equilibrium constant for the ionization of water. Die ewigheidskonstante vir die ionisasie van water, and we also call it the ionic product of water, die ionproduk van water. Okay. Waar kom hulle aan hierdie besigheid? Where do they get this constant business from? If you look there, if water dissolves in water. Okay, so as water in water oplos, dankie. You can either write it like that, or you can write it like this. Okay, but the point of the matter is, you get the acid particle, the suurdeeltjie, and you get the base particle. Okay, now most of you have had or you've drank water in your life before, eh? En toe jy hom gedrink het, was dit suur, was dit basis? Gewone water, nee? Water that you buy from the shop, not Parijs water. Acidic, base? No, it's...
Nee, is 'n basis, dit is baie water.
Nee man.
Dan is dit in boorgat, kan duidelik
boorgat is alkalies.
Boorgat is beter.
Nee. Anyway, ons kan nou hier filosofies raak oor water, maar water, gewone water se pH moet rondom 7 wees. It must be around 7, it must be neutral. It can be a bit alkali, but not too much. Maar hy is rondom neutraal. So dit sê vir ons that water won't actually dissolve in itself. You have water and you look inside, as you inzoom, then you just see a lot of water molecules. En jy sien nie baie van hierdie deeltjies nie. Okay, so it means it ionizes incompletely. It's a weak electrolyte. Pure water is a very weak electrolyte because it only ionizes very little. Klein bietjie.
Dis 'n paar van my H3O wat voor.
Ja, wat gaan vorm. Okay. So wanneer ons sy ionisasiekonstante gaan neerskryf, soos daai. Okay, en jy gaan doen die sommetjie, dan gaan jy baie klein waarde kry. You get a very small value. Maar sê my gou vinnig, does this ionization constant formula, is it sharp? Is it fine? Wat mag alles in 'n ionisasiekonstante formule kom? What phases? And gas. What is water?
Liquid.
A pure liquid. So water mag nie daar wees nie, want hy's 'n suiwer vloeistof. So omdat water 'n suiwer vloeistof is, then the constant formula changes to that. Okay. Now when someone, thank goodness someone did this, they did a lot of these experiments, baie experimente, en toe het hulle gekry dat when you have a pure and neutral water, then it means the pH must be around 7. Then the concentration, remember square brackets means concentration. Hoeke hakies beteken concentrasie. Die concentrasie van die suur, the acid particles, and the concentration of the base particles must be equal to each other. Okay, if you have more acid particles, then your water will be acidic. If you have more base particles, your water will be basic. So as jy neutrale water het, then these two must be the same, the concentration. And then, with a lot of experiments, they got the concentration to be 1 times 10 to the power -7. Dit is as dit neutral is. If it's neutral, then those two concentrations will be equal, that. En dan, as ons kyk na hierdie formule, if we look at this formula here, and you multiply the two concentrations together, you get 1 times 10 to the power negative 14. Okay, now you can see that's printed in bold. If you have your data sheet here, please open it up. As your data currently here, we still need it and then for the three of you. If you get Alright, so as your data file kind of splits into, okay, 4 chemistry obviously, en ek wil eens met gaan daar at table 2 about 2 here, then you will see that in the middle of the table, they give you this expression, hierdie uitdrukking. Hulle sê vir jou, die KW is that concentration times that concentration is 1 times 10 to the power negative 14. So daai uitdrukking, that equation is given. Okay, and that is important when you do calculations. You weet net, hy is daar vir jou. It's given to you. En ons noem dit die ionisasie konstante van water, the ionization constant of water. Dit is sy naam. That is its name. Ionization constant of water. Okay, so what I just implied is if the concentration of the acid is greater than the concentration of the base, then we have an acidic solution, a suuroplossing. And if the concentration of the base is greater than the concentration of the acid, we have a basic solution. So it's like a scale. As hulle gelyk is, neutral, acidic, basic. Okay, so hierso kan jy net 'n grafiek sien. Somewhere, if they are equal, then it's neutral. But if the concentration of the base becomes bigger, then the concentration of the acid becomes less. Okay, so hulle is altyd in balans met mekaar. Right, now here on the left-hand side, okay, your table is not that clear, maar kom ons kyk maar. On the left-hand side, they give you the pH, daar is die pH of the substance. You know the pH range is from 0 to 14, 0 to 14. Then it's the concentration of the hydronium ions. Then it's the concentration of the hydroxide ions. And then an example. Okay. So as jy daar in die middel, kyk, if you look in the middle, there we have water, pure water, that is neutral. So the pH is around 7. For a pH to be 7, then it will be neutral. En jy kan sien dis 1 mol 10 to the mag minus 7, 1 mol 10 to the mag minus 7. So they're both, the concentrations is the same times 10 to the negative 7. Kom ons kyk gou 'n bietjie hierso na jou bleach. Bleach. Nee, jig. As jy daar kyk, then you see the concentration of the acid. The concentration of the acid part. Is that high or low, Maritaba? Mama. So I'm at bleach. She did answer, didn't she?
She did answer.
Mama, stop pointing fingers. Use your common sense. Bleach, 10 to the power negative 13. High or low? Low. So bleach does not have a lot of acid particles. Maar sy basis deel is baie groot. That is 1 times 10 to the power negative 1. Okay, so you can see a lot of base particles, not a lot of acid particles. So bleach is eintlik 'n basis. Is 'n suiwer basis. Okay. Kom ons kyk gou na anti-acid tablets, nee, as jy sweebrand het of wat ook al, wat drink jy anti-acid tablets? Anti-acid? Nee? So hy elimineer die suur. Hoe gaan hy die suur elimineer? As hy 'n basis is. So you can see the acid part is small, the base part is big. Okay? Kom ons kyk gou na jou urine, jou piepie. Okay? Normale piepie, nie as jy iets fout het nie. Dan kan jy sien, your base part is smaller, your acid part is higher. So jou piepie is eintlik bietjie suur. Ja. Kyk, koffie is 'n suur. Koffie is more acidic. Okay? Tomato sap, acidic. Cool drink, Coke that you drink, acidic. Lemon juice, very acidic. Stomach acid, wat in jou maag is, very acidic. That is why when you vomit a lot, you burn all the flesh up here and in your mouth. Okay, so it's not good to vomit a lot. Right, and then battery acid. You can see how close stomach acid and battery acid is to one another. It's nogal span naby. Okay, now what a conclusion pattern can you see between the concentration of the acid and the concentration of the base in all of these examples? En al die voorbeelde, sê almal. Ja, maar ek wil nog, ek soek iets spesifiek. Wat is die verhouding of wat 'n patroon sien jy tussen hierdie konsentrasie en daai konsentrasie vir hulle almal? Ja, maar
Ek het gesê hoe hoor jy so
ja, maar so sê wat ek soek nie. Yeah, but that's not what I'm looking for. So maybe my question is wrong, but maybe someone picks it up. So, wat is die verhouding? Watter patroon sien jy vir elke, kom ek sê so, vir elke liewe een van hulle? Wat? Ja, nee, yes?
As from the second level, when you go down, it gets more acidic.
Nee, maar nee. Tjamo? Yes, no? Okay, ja? Ja, maar nog nie. Ja, Marie? Pragtig. Elke keer as jy dit met mekaar maal, then you get 1 times 10 to the power negative 14. 1 times 10 to the power negative 14. So that must be that way for all of the reactions that you do. If you multiply the concentration of the acid with the concentration of the base, it must give you 1 times 10 to the power negative 14. Okay, dis hoekom jy daai ander formule gaan gebruik. That is why you're going to use that other formula, and we're going to use it a bit later on today in an example. Okay, goed. Yes, can I go on? Right. Then we have a few indicators, indicatore, that we use to indicate if something is an acid or a base. Now there is a massive long list that you can use. Daar is so wat goeders. For example, purple cabbage kan jy ook gebruik. Nee, daar is so wat goeders. We are going to focus in grade 12 on these 4. We're going to look at methyl orange, methyl oranje, broomthymol blue, BTB, broomthymol blue, lakmoes of litmuspapier en phenolphthalein. Okay, daai 4. Phenolphthalein. Okay. Right, now when methyl orange is in an acid, then it will turn orange. When it's in a base, it will be yellow. So that color range is not a lot. Dit gaan na, maar die orange is soos Ouros, Nachi, cool drink orange. Okay, en die geel is soos lemoengeel. Suurlemoengeel. Okay, so daar's dus 'n groot verskeidenheid, right? But we use methyl orange just when we work with certain type of chemicals. When we work with a very acidic solution. So wanneer die pH baie laag is and we have a very acidic solution and we need to see that difference there on the acid side, dan gebruik ons methyl oranje. So ons gebruik dit wanneer ons 'n sterk suur en 'n swak basis het. We use that when we have a strong acid and a weak base. Strong acid and a weak base.
Is dit wanneer ons methyl oranje?
Methyl oranje gebruik. So wanneer die pH skaal laag is op die einde. Okay, broomthymol blue and litmus paper we use in the same instances when our pH range is in the middle. Okay, so when we work with a neutral end solution. Jy kan sien litmus of lakmoespapier het 'n groter range as broomthymol blou, but litmus paper doesn't change with one single drop, where broomthymol blue does change with one single drop. Okay, so hang af wat jy wil hê. Broomthymol blue, it's yellow when it's in an acid, and when it's in a base, it is blue. When it is neutral, it is green. When it is neutral.
So jy vra as dit ook as dit reageer met stysel of iets word blou.
Wat is jou mond binne sien?
Ja. Want hy begin al af te breek
En
die.
tandepasta is basis.
Hy is ook 'n suur. Hy is
Nee, ek dink hy's 'n basis. Wat het hy in?
Kloor.
Ja, my kalsium ook in. Ek weet nie. Goeie vraag. Baie goeie vraag. Yes, tomorrow? Ag, tomorrow. Sorry? It's like a light yellow. Light yellow. Okay.
Fluoried is seel.
Hy het vloer in.
Dis fluor.
Maar vloer is ook 'n suur, maar hang af waarmee hy gebind is. Ons kan nou kyk. Okay. Lakmus paper, it's red or blue, but when it's neutral, it is purple. Okay, now we use them when we have a neutral solution at the end. So of as jy het 'n sterk suur en 'n sterk basis, or when you have a weak acid and a weak base. A weak acid and a weak base.
Dat was experiment. Dat was experiment.
Gaan ze experiment doen.
Okay? And then phenolphthalein, it's colorless when it's in the acidic solution, and when it's in a base, it's pink, but so shocking pink, like a deep pink. All right, and that you use when you end with a high pH, meaning you have a strong base and a weak acid. A sterk basis in a swak suur. Okay, now I'm going to quickly show you a few reactions. I did not practice this beforehand, so it fails itself. And this is phenolphthalein. You can see it's colorless. Right?
Dat was 'n bos daar, maar.
We're going to do okay, and phenolphthalein we have to use when we have a strong base and a weak acid. Now the base that I have here is sodium hydroxide. Okay, strong or weak? Strong. Nitrogen hydroxide. Sterk basis. Now I have to choose an acid. I have here hydrochloric acid and acetic acid. I need a what? A weak acid. Acetic acid. Okay. Now hierdie asyn suur is concentrated, very much so, baie concentrated. So it might affect the reaction, whereas these concentrations are not that high. Okay, when we add an acid to phenolphthalein, it must be colorless. It must stay colorless. Okay. I should not be doing what I'm doing. Nee, iemand het dit nie ja, frozen. Okay.
Because in warm water bad sit.
Ja, hy is exodermisch, so hy sal ontplof as water bly.
Nee, maar jy praat oor water bad. As jy met water bad sit, dis goed. Dit is my vraag, as jy sit daar met die reaksie. Mamma, as jy water in jou in water bad. Juffrou, as jy hou in 'n waterbad sit.
Nee. Daar is nog wat okay, so this is the same one, it's just diluted, but it's very diluted. Okay, so it must stay colorless. You know, you can understand. Okay, and when we add the base, it must be what color? Pink.
Ons het net gedoen 'n eksperiment.
Dit is het gedoen.
Nee, as jy moet luister en
Wij,
dit moet so in.
Oké?
Dus ek wil aparte proef.
Ja, ek het nou net aan die ene kant aan my doen. Ek het baie van hierdie.
Wat is die middel tussen
Sure.
Okay, you can see the pink color. That is it, right? It's considered. Okay? So if we add the acid to it, okay, then go see.
Dan kan je het even.
Sure.
I added too much, now it turned to salt. Okay, but if we wait a while, tomorrow it will be colorless. So mooi opgroot. Ja, sien jy in 'n basis?
Mag gesê. Mag dit aan. Maar maak dit hy is trots.
Is it warm?
Ja, word bietjie, maar nie so warm. Alright. Then okay, so you saw now that was phenolphthalein. You saw the pink. You saw what's in the middle.
Wat is die middel tussen die keurlus en die pink?
Nee, ligte pink. Okay. Now I want to show you brimfimol blue. Okay, brimfimol blue. So in a base, brimfimol blue must be what? It must be blue. Okay? So with the base, brimfimol blue must remain blue. And when you add an acid, yellow. Okay, but when it's neutral, it's first green. Then we're okay. Woo, seem to feel. Yeah. Okay, I'm gonna say, oh, it's like
So hy groen ontwikkel so. Dis ook nou nie blou ding, dit moet so in.
Okay, so it's most of the time it's one drop, een druppel, maak dat hy neutraal is en dan een druppel is net. Okay, so ons kan nog 'n praktiese, we can do another practice wisdom where you do titration reactions, ons gaan oor praat, where you have that long tube en jy gaan druppel, druppel.
Dis altyd dis ek wat ek in was op ons in.
Ja?
Was